Today we shall discuss root locus using MATLAB. Okay. First, before going to the program, we shall solve the problem on root locus. Okay. The feedback control system has an open loop transfer function, that is g of s into h of s is equal to k divided by s into s plus 3 into s square plus 2s plus 2. Draw the root locus as k varies from 0 to infinity. First step, we need to find out that poles, zeros and number of branches, and p minus z is equal to, you'll get 4 branches approaching to infinity. Then we need to find out the theta 1, theta 2, theta 3, theta 4. Step 2, where root locus exists. In step 3, angle of asymptotes we need to find out, that is the formula theta is equal to 2q plus 1 into 180 divided by p minus z. Go on substituting the 0, 1, 2, 3. Then you'll get theta 1 is equal to 45, theta 2 is equal to 135, theta 3 is equal to 225, theta 4 is equal to 315. In step 4, find out the centroid, real parts of open loop poles minus real part of open loop zeros, that is 0, minus 3, minus 1, minus 1, minus 0 divided by p minus z is 4. You'll get centroid is minus 1.25. Breakaway point, 1 plus g of s is into h of s is equal to 1 plus k divided by s into s plus 3 divided into s square plus 2s plus 2 equal to 0. If you solve that, you'll get s to the power of 4 plus 5s to the power of 3 plus 8s to the power of 2 plus 6s plus k is equal to 0. Then next we need to k is equal to minus s to the power of 4 minus s to the power of 4 minus 5s to the power of 3 minus 5s to the power of 3 minus 8s to the power of 2 minus 6s. Differentiate dk divided by ds. If you differentiate with respect to s, you'll get minus 4s to the power of 3 and minus 4s to the power of 3 and minus 15s square minus 16s minus 6 is equal to 0. Next, solve for s. You'll get three equations, that is minus 2.288 and minus 0.7307 plus minus 0.3485j. Okay, complex conjugates cannot be breakaway point, so we will consider minus 2.288. Okay, step 6, intersection with imaginary axis. The characteristic equation is s to the power of 4 plus 5s to the power of 3 plus 8s to the power of 2 plus 6s plus k is equal to 0. Then s to the power of 4 1 8k. Next, in next line, 5 6 0, 5 into 8 minus 6 divided by 5, you will get 6.8. Next, 5 into k divided minus 1 into 0 divided by 5, you will get k. Next, for s to the power of 1, 6.8 into 6 minus 5 into k divided by 6.8, you will get next row, next column, you will get 6.8 into 0 minus 5 into 0 divided by, you'll get 6.8 is equal to 0. S to the power of 0 we will write as k, because a to the power of 4 is k. Okay. Next, from s to the power of 1, 40.8 minus 5k is equal to 0. K marginal we will get as 8.16. A of s is equal to 8.6 s to the power of 2 plus k is equal to 0. S to the power of 2 is equal to minus 8.16 divided by 6.8. That is, k value is 8.16 and you will get s is equal to plus or minus j 1.095. Okay. S square is equal to minus 8.16 divided by, that is, a of s is equal to 6.8. So I have said 8.6. This is 6.8 s square plus k is equal to 0. S square is equal to minus 8.16 divided by 6.8. You will get 1.2 minus 1.2. That is s is equal to plus or minus j 1.095, because s square is equal to, you will get minus 1.2, so that you will get s is equal to plus or minus j 1.095. okay, angle of departure phi p1 is equal to 180 minus tan inverse of 1 divided by 1 is equal to 135. 1 divided by 1, how you got? You can see in starting imaginary parts starting point, what you got? Minus 1 plus or minus j. That means real part, imaginary part divided by real part, 1 divided by 1. Next, phi p2, you can see the diagram. I have written the diagram there. Phi p2, you will get the 90 degree. Next, in phi p3, tan inverse of 1 by 2. How you can take 1 by 2? 1 is adjacent, okay, sorry, opposite. 1 is opposite and 2 is minus 3 minus 1. The difference is 2. So adjacent is 2. 1 divided by opposite divided by adjacent. That is a tan. okay, 26.56 you will get phi p3. Next, summation of phi p is equal to 251.56. if you add 135.90 to 26.56, you will get 251.56. Summation of phi z is equal to 0. Phi is equal to summation of phi p minus summation of phi z is equal to 251.56. Phi d is equal to 180 minus 5, you will get minus 71.56 at minus 1 plus j. Phi d is equal to plus 71.56 at minus 1 minus j. Okay. Step 8. The complete root locus is shown in this figure. You can see this is a complete root locus. They have marked the poles and centroid point and breakaway point and the terminating points theta 1, theta 2, theta 3, theta 4, and they have marked the breakaway point. okay. Next, they have marked the s values also. S is equal to minus 1, minus 1.09, you will get plus or minus j 1.09. That is also they have marked. Next, you can see the, now we shall go for the program. okay, how to write the program for this problem? First, write the root locus plot. okay, first write root locus plot. First, go for the MATLAB version. okay, after clicking on MATLAB, if you double click on MATLAB, you'll get this screen. Go for the new script. okay, after going for new script, write program percentage of root locus plot, numerator is equal to 0.00001. okay, because in the denominator we have 5 terms. okay, that is s to the power of 4, s to the power of 3, s to the power of 2, and s and some value. okay, k value, but we have don't know k value, so we have written as 0. okay, so in this equation, what you got in breakaway point, you can see that is s to the power of 4 plus 5 s to the power of 3 plus 8 s to the power of 2 plus 6 s plus k. That we will write as denominator 15860. okay, that is what I have written in the program 15860. That means there are 5 terms, so in the numerator 4 times 0, 1 is k is equal to 1, because there is a k in the numerator, so that I have taken as 1. okay, next, our locus numerator comma denominator. In next line, root locus numerator comma denominator. In next, fifth line, title. In graph, what title should be there? okay, root locus plot of g of s into h of s is equal to k divided by s into s plus 3 into s to the power of 2 plus 2s plus 2. In next line, x label real axis, y label imaginary axis. This is what you will get the graph. You can see the graph, it is similar to what we have done theoretical. Okay, theoretical relates to the theoretical what we got, that is poles. You can see this one pole, that is they have marked the poles 0, and you'll get the pole is -3, and other two poles have is imaginary axis, that is -1 plus or minus j. Okay, you can see, verify the what I have explained before. Okay, this graph and this graph almost it is similar. There are 4 theta values, theta 1, theta 2, theta 3, theta 4. Those 4 thetas are terminating at infinity. You can see this diagram, it is similar to the graph. Okay, this is what root locus example. Okay, you can take any other example and change the numerator and denominator, then you'll get the graph. Okay, thank you.